Hello and welcome back to Ganesh Institute. In today's video, we are going to take up another topic from differential equation, and that is exact differential equation. So far, we talked about how can we solve any equation using separating the variable method, and then how can we solve homogeneous differential equation. But what if an equation is of the type exact? How would we find out the solution of such particular differential equation? To know that, we should first know what we mean by exact differential equation. Okay, so it is an equation of the type mtx plus n dy equal 0. Now, it is important, this sort of equation will be called as exact differential equation only if it satisfies this condition, that partial differentiation of m with respect to y is equal to partial differentiation of n with respect to x. If this condition is satisfied, then we will say that this equation is an exact differential equation. And if it is so, then the solution will be integration of m dx plus integration of n dy equals c. Now here, what is m, what is n? This whole component m dx. We need to keep y as constant for this part. And for n dy, we need to take those terms of n which are totally free from x. Okay. So let's try one question. This is the equation given to us and we need to find out the solution. Question has not mentioned whether it is exact or homogeneous or linear. How would you solve it? Nothing is mentioned, only it is asking to solve. So firstly, let's check the criteria of exact differential equation. If I consider dx altogether and dy altogether, so this is x dx. So you can see here, this is the component of dx along with a square. I can bring it to left hand side, that is a square y upon x square y square dx, right? And then I can take this dx and dx common. So it will become this, right? Similarly, you can see this is y dy and this is the whole dy component. I can bring it to onto the left hand side again. So that means y dy minus a square x upon x square y square. And I can again take dy as common, right? I can see that, okay, it is forming that particular type m dx and dy equals 0. Yeah. But still I cannot say that it is exact until I find out that partial differentiation of m with respect to y is equal to partial differentiation of n with respect to x. So firstly, let's check it for the exact differential equation condition. Okay. So what is m here? If you compare, this is m. So I need to differentiate it with respect to y. And this is n. I need to differentiate it with respect to x. So when we do partial differentiation, that means I need to consider it only for y and x will be considered as constant, right? So if x is constant, this is 0. Now I need to apply the quotient rule here. Similarly, this is n and I need to do it for x. So this y will be constant. I need to only apply here quotient rule. Yes, let's do it. So it is a square y upon x square plus y square. And then this is my m. Yes, because x is anyways constant and I'm doing it for y. And here I have for x, I'm not considering y, only minus a square x upon x square plus y square. Okay, let's do it. So here, what do we do in quotient rule? Denominator square, denominator as it is, derivative of numerator minus numerator as it is derivative of denominator. Yeah. Here as well, denominator square. Then this is minus. Let's bring it outside. Denominator as it is, numerator derivative minus numerator as it is, denominator derivative. Yeah. Let's do it. So it becomes here for a square y with respect to y. This will be a square only because differentiation of y is 1. So it gives me x square plus y square along with a square. Yeah. Minus. Here I need to do it with respect to y. So x square is constant. Here it will be 2ay. I mean 2y because coefficient will come in for, but I mean the power will come as coefficient and then 1 will be deducted from power, so 2y. So a square y as it is and here 2y divided by denominator. What is here? Now I can distribute minus. Let's do it later on. So for this x square, I need to do it with respect to x. So it will be differentiation of x is 1. Only a square is left. So x square plus y square into a square. That is same, right? And then here, differentiation of this thing with respect to x. So y square is constant. X square is 2x. So it will be 2x into a square, right? So 2a square x square. And also I need to divide it by the same denominator. Okay. Let's solve it further. Distribute a square y square. So this multiply with this and this minus 2a square y square, right? Y square divided by x square plus y square whole square. Here we have minus a square x square. So this one minus a square y square and then minus minus plus 2a square x square. Divide by x square plus y square whole square. Now 2 minus 1 is minus a square y square. Here 2 minus 1 is 1a square x square minus a square y square on x square plus y square whole square. So can you see these both are equal? And if these are equal, so we can certainly say that yes, given differential equation is exact. And if it is exact, we know how to solve it. Solution is simply we need to take the integration of m dx. So m is what? Our m is this bit x plus a square y upon x square plus y square. And what is n? This whole y minus a square x upon x square plus y square. Let's jot it down. So x plus a square y upon x square plus y square dx plus integration of y minus a square x upon x square plus y square dy, and it will be equal to some constant. Now what I'm supposed to do, the condition is I need to consider this by keeping y as constant, and in it I need to take only those terms which are free from x. Okay, so let's do it. If I have to integrate, I need to consider y as constant. So x dx is what? It is left plus this a square y is constant, so let's leave it. Only this much is remaining. So a square y outside, dx upon x square plus y square, plus I need to take here only those terms which are free from x. So what's left? I cannot take this because it has x. Only y dy equals c. Now it's easy. This becomes x square by 2 because for integration we add one power and we divide it by the same. Yeah. So x raised to power 1 plus 1, 2 by 2. A square y as it is. Now this you can see is of the form 10 in 1 by a, 10 inverse x by a. Yeah. Because we are considering y as common. Consider it as 1 upon x square plus a square. Okay, consider it as a square. So 1 by a, that is 1 by y, 10 inverse x by a, plus again y dy, it will be y square by 2 equals c. Yeah. What can we simplify it further? This will be cancelled out. Only this much. So I can take x here altogether, x square plus y square by 2 plus a square 10 inverse x by y equals c. So this is the answer. I'm hoping that you've got a new concept, right? What is exact differential equation? How to check a particular equation as differential equation? And how to solve it. If you got these concepts, then don't forget to like, share and subscribe my channel. Till my next video, take care of yourself. Bye-bye.